In this video, we'll study the following topics: train resistance, adhesive weight, and coefficient of adhesion. Train resistance. This is the resistance offered to the movement of train. The resistance encountered by a train in motion is due to the following factors. First one is friction at the various parts of rolling stock. Second factor is friction at the track. And the last factor is resistance offered by air. So the first two factors, they are called mechanical resistance, and it is assumed to be proportional to the weight of the train, whereas the resistance offered by the air on the front end of the locomotive is known as head resistance, and on the sides, top and undersides of the coach is known as skin friction. Also, on the rear end of the train, the resistance offered is known as suction resistance. This is due to the forward motion of the train. The head resistance, it can be decreased by streamlining the shape of the engine, whereas the suction resistance, it is negligible since it is 1/16th times of the head resistance. The general equation of the train resistance is R equal to K1 plus K2V plus K3V square, where K1, K2 and K3 are the constants depending upon the train and track, and R is the resistance in newtons per ton, and V is the speed in kilometer per hour. So the first two terms represent the mechanical resistance and the last one represents air resistance. Next is adhesive weight. It is denoted by WA. It is the total weight of the train and locomotive to be carried on the driving wheels. Next is coefficient of adhesion, which is denoted by mu. The magnitude of tractive effort that is required for the propulsion of train depends on the adhesive weight and the friction between the driving wheel and the track. The coefficient of adhesion, it is defined as the ratio of tractive effort to slip the wheels and adhesive weight. So the coefficient of adhesion mu is equal to tractive effort to slip the wheels by adhesive weight, that is mu is equal to Ft by Wa. The value of coefficient of adhesion mu for clean and dry rails is 0.25 and the maximum value is 0.3 when the track has been cleaned with sand. For wet and greasy rails, the value of mu is between 0.15 to 0.2. The adhesive weight for electric traction is greater, hence it has greater amount of tractive effort exerted because for motor, coach, train, 100% of the weight is on the driving wheels, and for electric locomotive it is 70%, whereas for steam locomotive it is 50% or less than 50%. The value of coefficient of adhesion mu is greater for electric traction motors compared to steam traction. This is because of the following two reasons. In electric traction, the torque exerted by the electric motors, it is uniform and continuous, whereas for steam locomotive the torque exerted is pulsating because of cracking arrangement. This results in jolting and skidding. The driving wheels in electric traction, it is distributed over a greater length compared to steam traction where they are close to each other. Hence, the tractive effort in electric traction is much greater. Let us see the numericals on adhesive weight and coefficient of adhesion. First problem, a locomotive accelerates a 350-ton train up a gradient of 1 in 100 at 0.8 km per hour per second. Assuming the coefficient of adhesion to be 0.25, determine the minimum adhesive weight of the locomotive. Assume the train resistance as 44.5 Newton per ton and allow 10% for the effect of rotational inertia. So the given data we have is W equal to 350 tons. This is the weight of the locomotive plus the trailing load. And we have the accelerating weight WE equal to 1.1 times W, since rotational inertia effect is 10%. So it is 1.1 times 350. It is equal to 385 tons. And we have the percentage gradient equal to 1 in 100. So the percentage gradient is 1. And acceleration alpha is 0.8 kilometer per hour per second. And coefficient of adhesion mu is 0.25. And the train resistance R is 44.5 Newton per ton. We have the coefficient of adhesion mu equal to the tractive effort to slip the wheels, that is Ft in tons, by the adhesive weight Wa in tons. We have the equation for Ft equal to 277.8 We alpha plus 98.1 Wg plus Wr, that is equal to 277.8 into 385 into 0.8 plus 98.1 into 350 into 1 plus 350 into 44.5. So solving this, we get Ft equal to 1,35,472.4 newtons. So the adhesive weight WA is Ft in tons by the coefficient of adhesion mu. So converting Ft in newtons to tons is by the term 9.81 into 1000. So we have WA equal to 135,472.4 by 9.81 into 1000 into 0.25. So we get the value of adhesive weight as 55.23 tons. Next problem. A train weighing 200 tons is accelerated up a gradient of 1% with an acceleration of 1 km per hour per second. Determine the minimum adhesive weight of the locomotive. For this purpose, if the coefficient of adhesion is 0.2. Assume train resistance as 50 newtons per ton and allowance for rotational inertia as 10%. We have total weight of train equal to weight of the locomotive plus the trailing weight. So W is equal to WL, the weight of the locomotive, plus trailing weight, that is 200. It is in tons. And we have gradient of 1%. Acceleration alpha is 1 kilometer per hour per second. Coefficient of adhesion is 0.2. The train resistance is 50 newtons per ton and rotational inertia is 10%. Therefore, accelerating weight is 1.1 times W, which is WL plus 200. We have the equation of tractive effort Ft equal to 277.8 We alpha plus 98.1 Wg plus Wr, that is equal to 277.8 into 1.1 into WL plus 200 into 1 plus 98.1 into WL plus 200 into 1 plus WL plus 200 into 50, that is equal to 453.68 into WL plus 200 in newtons. So Ft equal to 453.68 WL plus 90,736 newtons, or Ft is equal to 453.68 WL plus 90,736 by 9.81 into 1000 in tons. The maximum tractive effort possible with weight of the locomotive WL is mu WL. So we have mu WL equal to Ft in tons. That is mu WL is equal to 453.68 WL plus 90,736 by 9.81 into 1000. We have mu as 0.2, therefore 0.2 into 9.81 into 1000 WL equal to 453.68 WL plus 90,736. So we have this as 1962 WL equal to 453.68 WL plus 90,736. So we get 1508 WL equal to 90,736. Solving this, we get WL equal to 60.15 tons So this is the minimum adhesive weight of the locomotive.